Hey everyone, welcome to your video lesson for Unit 2.5. Today we're talking about composition of functions and domain. So this is really building off of what we did last time with operations of functions, because composition is considered another operation, okay? And figuring out the domain of the resulting function. Okay, the rule here when you do composition, just as a review, okay, we always work from the inside out, okay? If you're using F circle G, remember that means you work from right to left. Okay, so composition is plugging one function into another. Okay, so really quickly, how do we do composition? Okay, so working inside out, we're going to take G of X and plug that into F. So anywhere that you see an X, you're going to replace it. Okay, remember that when you square a binomial, that means you have to FOIL. Okay, and then we will distribute. Okay, and that is our resulting function there for composition. Okay, so now we want to do this with our functions, and we're going to have to consider the domains. Okay, so to find the domain of a composition, we first need to know what the original domains were. So this is exactly like we did in operations of functions. Okay, the difference though, okay, now the domain of the composition is going to take on the restrictions of the function that was substituted in. So when you work from the inside out, whatever function is inside, we take those restrictions and we take the restrictions of the resulting function. So if we have square root of x and x minus 2, okay, so for the square root, we know this has to be limited to positives. G of x is linear, so there's no limitation there. Okay, if we compose f of g of x, okay, that is taking x minus 2 and plugging it in to the square root. Okay, so G was on the inside, which means we're considering the limitations from that domain as well as the limitations that you get from the new function. Okay, so technically 0 to infinity, that domain has no bearing on this situation. Okay, well, the domain from G of x has no limitations because it's negative infinity to infinity. And the new function is now a square root, which means we would have to limit that to be positive numbers. We would do that by 2 to infinity, because remember, we would take what's underneath and set it greater than or equal to 0. Okay, so let's try some examples. Okay, so here are our first two functions. So f is a linear, which means it's going to have a domain of negative infinity to infinity. Okay, g is rational. So for the domain of a rational function, we have to look for wholes and vertical asymptotes. Well, I can see that nothing is going to factor and cancel here, but I do have a vertical asymptote at negative 4. Okay, because of that denominator. So my domain is going to skip over that value. All right, so now we're going to do composition in both directions. Remember, composition is not commutative, so f of g of x is different from g of f of x. Okay, so first thing we're going to do is take our rational function and plug it into f. So that means 2x plus 3 over x plus 4 plus 1. Okay, now in order to find the domain of this, we do want to make a common denominator. Okay, and have this entire expression be one fraction. So I'm going to take 1 and multiply top and bottom. So I get a common denominator. Okay, so now when we think about the domain, we're using the restrictions from the domain that was substituted in, as well as the new function. So this is our new function. So we have to consider what the domain of that would be, and we have to account for the domain of g. Okay, because g is what's on the inside. So we have to take into account this domain as well for our new final answer. Okay, well, if I look at the new function, nothing will factor and cancel, so I'm not going to create any holes, but the denominator could be undefined, and that would be a vertical asymptote at x equals -4, okay? And that is not any more specific than the original domain from the function that was substituted in. So my new domain can be the same. Okay, let's try g of f of x. So now we're going to plug x plus 1 into the rational function. Okay, so that is my new function, and we're taking into account the domain from f, which was -infinity to infinity. So that has no restrictions to it. So we're going to look at the restrictions of the new function, which is going to be a vertical asymptote at -5 because of the denominator. Okay, so we're now going to make that original domain from f more specific because the new function cannot include -5 in the domain. Okay, so that was our first example. All right, different types of functions now. So what kind of function is f? Hopefully that we realize from the squared, it's a quadratic, and that always has a domain, -infinity to infinity. G is a square root, and what do we know about the domain there? Must be positives. Okay, so in this case, we would say it had to be greater than or equal to 0. So this gets me 0 to infinity. All right, so we're going to do both compositions. So plugging g, which is the square root, into the quadratic. Okay. When you square a square root, they cancel, and we get x. Okay, so the new function, x, is just linear, which wouldn't have any restrictions to the domain. But remember, we have to take into account the domain of the one that was substituted in, which was 0 to infinity. So between those two expressions, okay, this one would technically be -infinity to infinity, the new function, and 0 to infinity, which one is more specific? Okay, we actually have to use 0 to infinity because we're taking into account the domain that was used to create it, which came from g of x, as well as the domain of our new function. Okay, for g of f of x, we're now going to plug the quadratic into the square root. Okay, so this is the same situation where the square root and the squared cancel. So the new function is x. Okay, and we know that just x is linear, and the domain would be negative infinity to infinity, but we also want to take into account the domain from the function that was substituted in. And the domain of f is negative infinity to infinity. So I have no restrictions from either of those. So this domain can actually be negative infinity to infinity. So we see in this example, our new function, the expression that we end up with, is the same. Both of them come out to be x. However, the domains are different because in each situation, you're taking into account the domain from the function that was substituted in. So in number 1, okay, you have to take into account the domain of g when you're creating your final result domain. And that had a restriction of 0 to infinity. In number 2, f of x was considered when writing our final domain, and that had no restrictions to begin with, which is why number 2 can be negative infinity to infinity. Okay, so that's why it's important that we take into account the original domains. Okay. So for our last example, we're going to look at a square root and a rational function. So the square root function, the x minus 1, would have to be limited to positive numbers. So that would have to be greater than or equal to 1. So that gives me 1 to infinity. In g, my denominator could not be equal to 0. So that's going to have negative infinity to 0 and 0 to infinity for my original domain. Okay, so working on my composition now. For number 1, I'm going to plug 1 over x into the square root. Okay, I'm going to want to make a common denominator inside. So I'm going to put the whole number over 1, and I'm going to multiply top and bottom by x. Okay, so that I can put these together as 1 minus x over x. Okay, so that is my new function. However, we've never seen the square root of a fraction as a function before. We don't know how to handle that. But the good news is with square roots, we're allowed to square root the top and square root the bottom. This is now something that we've seen. Okay, we have seen rational functions where there's a square root in the top and a square root in the bottom. And we know how to handle the domain for that. Okay, so let's first think we're going to take into account the domain from g. Okay, which excluded 0. And now we want to look at the domain that we would get from this new function. So in the new function, I know that 1 minus x would have to be greater than or equal to 0 because that's a square root in the numerator. Okay, so that portion gives me x is less than or equal to 1. Now the square root that's in the bottom would have to strictly be greater than 0 because the denominator can't be 0. That would make this undefined, but it's still a square root. So it has to be positive, but you just can't include 0 on that one. So now I'm looking at 2 expressions here for this rational. And remember, when we do this type of problem, we have to pick the more specific. Okay, we have to satisfy both of these. So if we have to be greater than 0 and less than or equal to 1, okay, where do we satisfy both of these? Okay, that would be the only place where I could satisfy both of those. Now, I want to compare from 0 to 1 with the original domain. Okay, so I'm looking at 0 to 1 here, and actually that's not right because we're not including 0. Okay, because that's an open circle. So now I want to compare 0 to 1 with the domain from G. So 0 was not included. Okay, that follows for both of them. And then my new function only goes up to and includes 1. The original went up to infinity. Okay, so all that means is that 0 to 1 is more specific, but 1 was included in this original domain. So, long story longer, this is my final domain, okay, for that simplified function. Okay, for g of f of x, we're now going to put the square root into the rational function. So this is going to end up being 1 over the square root of x minus 1. Okay, so we're taking into account the domain from f, okay, because that's what's being substituted in, and that was 1 to infinity. Okay, so now the domain of this new function, well, since the square root is now on the bottom, not only does it have to be positive, but it can actually equal the 0. Okay, so this new function says that I can do greater than 1, but now it's not included, whereas the original said greater than 1, but it was included. So how do we make this to satisfy both? Okay, so that you satisfy the more specific, we're just going to have 1 to infinity where 1 is not included now. Okay, so there's a lot more to think about when you're doing the composition of functions, okay, because you're only taking into account the one that was substituted in, and you definitely get more complicated resulting functions than you would with basic operations of addition and subtraction. So you can see here in this last example, you know, f of g of x, that's definitely a more complicated function than you would have gotten if you tried to just add these two together or, you know, subtract them. Okay, so these are your examples for composition. Please make sure that your notes are complete. Write down any questions that you have, and we will go over them when I see you the next time. All right, thanks for watching.